obviously call me Anirudha or Ani for short. I've been working with blockchain since 2016, the first time I heard about blockchain. And after that, we started this Blockchain to India community. It's an open innovation community where, and currently it's the largest community in India. We have 4 active chapters in Delhi, Mumbai, Hyderabad, and Bangalore. Based out of Bangalore. There are other folks in across other parts of the country. And anybody is free to join. It's an open community, obviously. We have very active groups on Telegram and Facebook groups. I'm not very active on Facebook, but Telegram I'm pretty active on. And the idea with Blockchain India was that when we started, nobody was really talking about blockchain. People were talking about it back in 2016, 2017. People were talking about how to buy and sell bitcoins and manage your crypto wallets and so on, which does seem fascinating because crypto itself is fascinating. However, it gets it hugely involves a lot of trading and all that. So that did really attract me a lot. But when I heard about blockchain and what it can do, that really fascinated me. Fast forward a year or so later, I founded a little startup called Acyclic Labs, where we were building this product called Sentinel. What the idea was to build a protocol which will allow anybody to interact with a public blockchain without having to use cryptocurrencies. And we did that with partnering with Kotak Mahindra Bank. We got into the Cisco Launchpad program and went on for a while. We built applications in the fintech sector, in supply chain logistics sector, and in the documentation and certification sector. Recently, I joined IOTA Foundation as a developer advocate. We will talk about what IOTA is and what role it will play. I got fascinated with IOTA when I first heard about it because of some reasons which we will actually look into a little bit later. All right. So let's roll back a decade ago, to the pre-blockchain era, or at least the era that we were not aware of any digital cryptocurrencies out there. Bitcoin came into being around 2008, 2009-ish time, but it actually started gaining momentum around 2011-ish time. When a lot of people just started using it or playing around with it and so on. But really, blockchain actually took over with Ethereum and all that. But what was really happening, and why did blockchain actually took off the way it did? One of the major reasons in traditional industries is huge fees in money or asset transfer. So even with the banks, like banking networks are the only networks that exist in terms of transferring monies or assets across borders, across industries, across institutions, and they charge a huge fee. PayPal came into during the dot-com bubble time, and it took off as one of the first to revolutionize the online payment industry. That really, it became sort of like the first thing. For the first time, people will be able to integrate an online payment network into sort of like a website or an online payment system, which really did not exist back then. In fact, even now, if you look at the bank's APIs and all that, I hope you know what APIs are. It's just the application, the programming interface that you connect to via HTTP or HTTPS and other protocols. And even with that, if you look at the banking infrastructure right now, it's not a very good infrastructure. And I know because we have integrated with the banking infrastructure, and the documentation really isn't up to the mark. I mean, not up to the mark is an understatement. Is really in a bad shape. And with all of that, a lot of reconciliations happen, a day or two later, and the entire infrastructure is a huge mess. Obviously, because of these reasons, the huge fees is justifiable in the banking network industry. And not just that, because of these other lack of infrastructure, it's actually delayed a lot. So if you are working for, let's say, a foreign company, or if you have worked for a foreign company, they would ideally transfer you or wire you funds, and that will actually reach you a week later, sometimes a couple of weeks later. Even with PayPal, the settlement period, it's around 3 to 5 days. So at least you have to wait for 5 days to get your money, even after the other person would have sent it, right? Controlled by the government or institution. It's obviously controlled by the government or institution. They can, at any given point, raise taxes on it. They can, at any given point, ban something. They can stop a Visa card or MasterCard about working, which is happening right now. If you know about it, they can just, and even before the government, there was this institutions like individual organizations who created their own syndicates and so on to control certain flow of money in certain markets. And obviously, corrupt humans. You can't really trust anybody. If I as a random stranger come and tell you that, oh, you know what, just give me 1 lakh rupees, and I'll safely deliver it to your other person who is living in sort of US or somewhere, you wouldn't trust me, because why would you, right? You don't know me. But if it's say somebody of your a relative or a family member of yours, you'll probably trust them because you know them, right? So even if it's your own, let's say, batchmates or somebody in your own college, you probably wouldn't trust them with a large amount, with large sums of money. They might just take off some amount and say that, oh, it got lost in transaction or somewhere in between. So the solution that came up was blockchain. And what blockchain brought with Bitcoin was the first trustless system. You don't need to trust anybody. You can just get somebody's address, which is a public address, and you can just transfer tokens directly to them. You can even configure something, and this would happen, across borders. There's no concept of paying tax on every border that you cross. Just going back to the very, very old age when the Silk Roads and all those trades used to happen, and on every country change, they would have to pay some tax into that country. Now, this is a very, very advanced system. Blockchain paved the way for more distributed data systems. Distributed data systems were available even before blockchain. So if you know about Cassandra or something, or some other distributed databases, they existed way before as well. But blockchain actually brought those things together. It made all of that mainstream, so to say. Peer-to-peer networks gave people the control back, which at this point was only in the hands of big organizations. Now with Bitcoin, you don't have to go to anybody. You can just run a node on your own laptop, and this obviously I'm talking way back in 2009, 2010. Where you could still use your laptop as a validated node, and you can transfer that digital coin to somebody else, and you can even validate other people's transactions, and you will be rewarded for the same, right? And it will be right on your wallet, and you can spend it for whatever. You can buy a pizza with it or something. if obviously the pizza shop, or they accepted the bitcoins. With that, I mean, internet faced a revolution like none other. Like right after the dot-com bubble, this supposed to be sort of like the next thing that is happening, and it's still happening actually. People are still realizing after 10 years that the actual potential of bitcoins and blockchains. And you can now create incentives, so if you are dedicating your machine to validate somebody else's transactions, you get a reward for your hard work, for dedicating your resources of your systems. You get in the form of gas fee or the miner fee, right? So this actually encouraged a lot of people to actually put up their own systems into setting up validated nodes. Now, but there were obviously certain problems that came along with it, with blockchain. Users versus network. Now, it was all fun and good when it was like, say, 5 people or 10 people, 100 people, 1,000 people. But it just, when it blew up, the network became very, very huge. And as the number of users grew, the network grew, the more the number of transactions started happening, the network started slowing down with like crazily. Like, it was crazy to see how much time it would take for one transaction to get in. If you compare right now, like Bitcoin probably just like Ethereum blockchain probably confirms 25 to 35 transactions per second, which is very, very low. The traditional Visa, or they sort of process 1,000 transactions per second. So like, why would you use blockchain with 35 transactions per second when you have something like Visa, which is processing 1,000 transactions per second? So people started asking these questions now with blockchain. Scalability. So this brought in the issue of scalability. Now, once you see that the network is slowing down, the network management started becoming a big issue. So people started asking, this is not a scalable solution, obviously. We'll probably have to figure something else out. And the data size also keeps on growing. Like, we'll have to obviously figure out a way that with the growing network, we can still manage it. So people used to see that with 100 people, it would probably be 1,000 transactions per second. But as the network grew to like a million, billion, trillion people, trillion transactions, which is trying to pump in every second, it just slowed down and down. So this is obviously not a scalable solution. The tax on the miners, that actually grew heavily. So if you know about ICOs, which are the initial coin offerings, which started around a while ago, and it was on huge demand around 2017, 2018. People were actually paying tens of thousands of dollars just to get a piece of that ICO. There was actually one of the ICOs in which somebody paid $10,000 to actually invest like $1 million to it. Now, this is obviously a huge issue. Like, imagine a scenario where you're trying to buy 1,000 rupees or 1,000 rupees chair from Amazon, and you're paying 10,000 rupees in gas fee or the miner fee. That is obviously not something that you would want to go along with. And yeah, you obviously have to be always online. So because you have to be synced, your node or the network, your servers, you have to be synced with the blockchain that everybody is using. If you slow down, you'll have to keep syncing till you can actually start pushing blocks again on the blockchain. So you'll obviously always have to be on it. And this, however, makes sense for a lot of advanced countries, but for countries like us in India, this does not work at all. We face a lot of issues, even in metros, staying in metros where you don't get proper internet connection, or you get internet connection, but it's very flaky, or it keeps getting disconnected. This will not work. I mean, even in an online presentation, if internet goes off, you have you have to connect with your mobile data or something, and this obviously would not scale properly. High-end hardware requirements. Now, as the number of transactions grew, people started like the proof of work, like the validating part of thing. It started getting very complicated. So CPUs got exhausted way back in 2009, 2010. They started using GPUs in 2010. By 2011, even GPUs started getting outdated. They were not able to handle the computational resources that was required, and they brought in ASCII chips. Then server farms started. People started colluding with each other and so on. Like the hardware requirements never stopped, and it's still like one of the very major issues. And because of these hardware requirements, obviously, the internet charges are like it's actually going in a phenomenal way. Um, According to this one survey report, just last month, the entire consumption of the Bitcoin network is actually almost equal to the entire energy consumption of an entire country of Pakistan. So, I mean, I imagine that like that's really a very major concern for the environment even. And data overflow, right? So, and as like blockchain is an immutable ledger, right? So if you write something on the blockchain, it will remain there forever. Uh, which is good to know theoretically. But if you really think about it, um, we are not deleting anything. We are keeping everything. And now there's like a million people who's using this network, and we are not deleting anything. So we have every random piece of information up on the blockchain that has been from the beginning of time, or as in the blockchain terms, it's called Genesis, right? So the huge data management became a huge problem, right? And you would need large scale servers or data centers to actually store these things. Um, our normal laptops or home desktops would not at all fit the capabilities of doing that. You can obviously figure out other types of nodes to run, like light node or something, which doesn't require you to have that sort of data to store everything. You can just run the validated node or something like that. But that's where the problems of blockchain came in. Now, some of the solutions also came up in the blockchain industry to some of these issues. For users versus networks, there came different types of consensus mechanisms. So Bitcoin followed something called proof of work, which means that you have to process every transaction in the validated node to a certain computational to a certain computational aspect, and only then it will once you can prove that, only then it will be accepted into the network. A lot of different consensus algorithms were actually introduced. In case you're not aware of any term in between what I'm talking about, feel free to leave a comment, and I'll get right back to explaining that. Consensus is basically just agreement of what we as a group will decide to do, right? So blockchains work on consensus-based algorithms. So different consensus algorithms came in, like proof of stake, proof of authority, proof of burn, proof of time, and so on. Like there's hundreds of consensus algorithms by this time. And it all obviously originated from the original BFTs, the Byzantine fault tolerance, and so on. So different consensus algorithms like proof of stake. Right now, Ethereum 2.0 is working on, and that is being worked on proof of stake, which will obviously solve a lot of issues in the growing network. It will speed up to a certain extent, obviously. Proof of authority will probably be a little more faster. It works on a round robin fashion, and it can perform a lot better in terms of speed of the network, and probably can even. So we were running a proof of authority network, and we were processing around 300 requests per second. So that was a considerable amount of jump, almost 10x jump to actually, we could have bumped it up even more, but we didn't have that many users using our network. So it can probably go up to 1,000 requests per second as well. Scalability. Now, the scalability issues with the main network, once those things came in, people started coming up with different types of solutions, like Lightning Network, Radio Network, Plasma, sharding, and so on. Now, some of these were a layer two solution. So the layer one you can imagine as the first blockchain network, and layer two you can imagine as the next. As an alternate or a parallel network which is running, which will actually do process a lot of these things, and then only send what the final transactions to it. So, for example, let's say if I say that we have to come to a decision on whether to use, say, Airtel or Geo as a network. And this is the entire group. I think there's around 32 people over in this call, and let's say we divide into two smaller groups, right? And 10 of us go to a separate room. We discuss about amongst us, and we come back with a conclusion that, okay, these 10 people have already decided that we're going to use Airtel. 20 of us just go to another room and we decide, and we come back with and we do. So the advantage is that these 10 people, like, once they have decided, like, all that discussion, whatever happened, is happening in a separate room, which is the layer two solutions, right? So a lot of these scalability solutions have come in, which is obviously, which will obviously help out in towards the scalability. For the tax versus miners, there is no solution. If you're using a public blockchain, there is no solution. You have to, pay certain amount of fee attached to it, unless it's a private blockchain where probably somebody else is taking care of the gas fee or the miner fee. So you don't pay for the transaction, but you pay with your data and so on. Always online, there is no solution. Obviously, still. Some of the layer two solutions can arguably be parallel solutions, but it's not a offline network solution. So it's still not really there with an alternate to always being online, or you can work offline and then come back and share the result with the class about what you already decided. For high-end hardware requirements, some of the light chains solve to a certain extent where mining is not involved. So you can essentially run an Ethereum light node on your own laptops, and you can try to sync it so that you don't have to do the mining part or the proof of work part on your own device. It can happen like somebody else can do it, and they will get the validator fee or the mining fee and so on. But all you are doing is pushing onto your own network on your own node, so the IP of it, and you can connect to it to your decentralized application or dApp, and you can process from there. For data overflow, some solutions came up with offline storages, like cold storages and huge data farms and so on. Now here comes the Tangle. What is Tangle? Tangle is the IOTA's alternate to blockchain. It's a distributed ledger technology, like blockchain, but a little different, right? So let's get on to what exactly it is. Now, if you see the image on the left side, you will see what a blockchain is. It's like a linked list, and or it's like a train. I am assuming that since you mentioned most of you have tech background, so different data structures. So the blockchain is like a linked list. It will keep attaching to the end node, and it will keep growing in singular direction. A tangle is more like a graph. So there is no one singular end node or leaf node to it. There's multiple leaf nodes or end nodes to it where you can attach your transactions to. So that gives a lot of advantages. So like as you can imagine, like just to just to understand from the terms of speed of transactions or the speed of confirmations here, you will have to wait for one transaction to attach to the chain, and only then you can attach to it, and so on, and grow the blockchain. But a Tangle, you can just attach to multiple leaf nodes. If one leaf node is busy, you leave that, you go to the next leaf node, and you attach to that, and so on. And you can grow, in a pretty graph way. So this particular sort of graph is called DAG, or directed acyclic graph. What directed acyclic graph means is that there would not be acyclic by itself means that it is there would not be any cycle attached. There would not be any cycle, so it will probably just go around into other directions, but it will never come back and reattach to the previous nodes. So if you want to obviously read more about IOTA, I would recommend you to read IOTA white paper, in which it is very nicely described about all of this, about all of this, and you can obviously read through the architecture and the decisions, why they did what they did, and so on, right? It also does proof of work, by the way, but it's so minimal that it's way faster. So we'll see how it actually works as well. So far, if you have any questions, feel free to add it to the comments again. Now let's dive a little bit deeper into what directed acyclic graphs, or DAG, means. Right, so it's a finite directed graph with no directed cycles. That's what in mathematics and computer science it means. So what it means is that it will start from, let's say, one root node, and it will keep on growing in one direction, right? And this direction will keep on spreading on and on. So if you see, there are different types of confirmation states as well here. Like, these are fully confirmed states. You'll have to have at least certain n amount of transactions already that you would have validated to be into that state. These are unconfirmed states, so they are attached to the tangle, but they are still unconfirmed. And then these are the tip nodes, which is still looking for new transactions to attach to, right? So adding a transaction, how does a transaction gets added? So if this is a transaction, it will try to find a transaction which is like the leaf node of it, and it will try to attach to it. That's what a usual blockchain does. But in IOTA, in this case, it's actually the other way around. So the leaf node will try to find an ideal transaction, and it will attach, and it will try to confirm it, right? So this like, let's say W found 1, and it tried to confirm it. X found 1, it tried to confirm it. Now, once a transaction gets confirmed by two or more than two existing leaf nodes, it's said to be that it is that then it gets actually attached. And once those transactions confirm 2 or more other transactions, then it gets fully confirmed. So it will be there. So you know that will be there permanently on the network. Now, what happens if you add another? What happens when another transaction comes in? So at this point, while this is getting confirmed, if 2 comes in, it doesn't have to wait for 1 to get confirmed. So Z can just find another transaction 2, and it will confirm that, and Y can find another transaction 2, and that will confirm that. And this can actually spread out and keep on doing. So X can even confirm 2, and so on. So the the difference between this image and this image, if you see, now once this is confirmed, now we know that this particular state is pretty much in. So the next image that you see, like if you notice the difference, it is going into, like, if you draw the Venn diagram or something, it is the n has sort of the most number of transaction confirmed in terms of the common grounds of it. So when that happens, this actually gets fully confirmed and it's on the network. There are obviously certain disadvantages to this approach. We'll come back to it, but ideally it takes a while even after getting attached to the network to get fully confirmed. So that is one thing that we have to obviously keep in mind of when dealing with Tangle. Now, all right, now we have added, two more transactions, and now you can see that X is confirmed 1, X is confirmed 4, Z is confirmed 2, and so on. So now in this case, we have multiple sort of confirmation levels, which is now growing. So now our network is really busy, right? And this will keep on growing and growing. Now, the next thing that will happen is, like, now what will happen if the fifth one comes in and these nodes start confirming it. So now if you see, something very interesting happened here. At this stage, N was fully confirmed, but when the fifth transaction came and Q and S confirmed the fifth transaction, the common grounds moved from N to actually M, and this became the intersection of it, right? So even after you're fully confirmed, it's not a guarantee that it will stay fully confirmed the next second when the new transaction comes in. Obviously, after a time being, it will get again fully confirmed. Now this state is actually called propagation delay, right? So there might be that, say you have paid a certain amount to somebody else, like let's say Amar in this case, and that is being reflected in your wallet, but due to some reason somebody else paid, like I also paid certain amount to I paid certain amount to you, and what you will see is that it might so happen that this actually got attached to a different node, a different leaf node or something, and due to which now that amount that you have already transferred is not being visible anymore. That doesn't mean that that transaction is gone forever. It's still there. It's just that it is getting a bit more delayed. So it will wait for another transaction to come in, and for these leaf nodes to sort of verify, for this to again get inside that inside that common ground. So this leads to this interesting problem of double spend. In blockchain, this is actually much simpler, obviously. So there is a little bit of disadvantage to Tangle, in just temporarily in this case, because the double spend might be an issue. Now, but at the same time, this won't happen forever. Even if let's say W and Y in this case, let's say they are conflicting transactions, but one of them will be discarded. Now, which one will be discarded will depend on how this network has grown up on. So, for example, let's go back and let's check. Let's say this M transaction, right? So let's imagine if M and N were conflicting, and more and more nodes started, more and more transactions started joining in this particular way. The network grows in this order. In that case, N will be discarded eventually. So that will happen. And that's how you avoid a double spend in case of an IOTA Tangle. If it's getting too complicated, do let me know. I'll probably try to explain this a little more. All right, and so that's how the double spend resolution happens. So in the previous one, obviously we saw that when 5 came in, this became like the conflicted transactions. We got to know that, oh, this particular person has already paid 100 rupees. Now it doesn't have 100 rupees to pay, but he has paid 100 rupees to two different persons in one transaction, and here again. So when 5 came in, it actually said that this person is broke. How do you already pay this? So when that happens, like when more transactions comes in, so you will see now that more transactions are getting attached to this side of the network. So this will probably get discarded, and it will get cut off. What will happen? Okay, so now this was a wrongful transactions, but what will happen to 2 and 3 and 7? They were genuine transactions, right? So they can reattach to the network. So there is a function of reattaching, so they can reattach, and they can again reconfirm on the network. And so with that, what is happening is you can reattach any number of times until you are fully confirmed. Uh, Now, what really happens is that when Z actually confirms these two, there is no miner fee in there, because it's not exactly mining. You're not mining somebody else's transaction. You're not validating somebody else's transaction. There is no validators like there is no concept of validators. When you want, like it's up to you. If you want your transaction up on the network, you will confirm 2 other transactions that comes in after you, and so on, and it will keep on happening. So it's in your best interest to confirm 2 other transaction to get your transaction up on the network, right? Now, this gives rise to some very interesting use cases, especially offline tangle. So you can imagine that there's a separate offline transaction, offline tangle, which happens. Like, let's say we are working in an enterprise use cases where we're working on something in an offline transaction, in an offline tangle way. And once all the stuff is done and we get internet connection, we can attach to it. So the leaf nodes, the root nodes in this tangle will attach to one or the other ones, and they can keep confirming the other transactions as well. And the leaf nodes of this offline transaction will find available transactions to confirm on the main network. So once that happens, this offline transactions the entire network gets reattached to this. This has some very useful use cases. Not just in terms of if your internet isn't available, so let's say let's say it's a vehicle, right? While on the road, there might be that it's not getting a steady internet connection. So in that case, it will keep working on itself. Like, you can keep scanning something, and you can keep accumulating data on the device itself. And once it reaches, let's say the depot or somewhere, it will get internet connection, and it will just sync up everything with the main network. We actually did a similar use case in terms of when we were building this coffee traceability application for the Karnataka government, and we were tracing tribal coffee. Now, in these tribal hill areas, there is hardly any network, and I went there, and there was no network at all. So how do you scan those bags of coffee and and still make sure that there is no mischief behavior happening? So you can scan those, and all that validation, all that validated transaction will remain on your mobile device, or it can be a network of mobile device like a LAN system. And once you are back into the city or somewhere where you have internet connection, at that point you can just click on this button, which will sync to the online, to the main network. It can also be an automated process. As soon as it finds the network, it will start syncing. But this is a very important, very useful, actually very practical use case. All right, so that's how the tangle actually works. Right. If we talk about scaling, theoretically, because of how it actually works, it can keep attaching multiple sites to it. So this actually got proven down. With the increase, the more the number of transactions become, a blockchain will get bloated and it will slow down. A tangle will actually get faster and faster and faster. So theoretically, it's infinitely scalable. Theoretically, there are obviously certain thresholds that it might hit at certain point, but theoretically it will scale infinitely. So imagine a scenario where you have to catch 2 balls So where you have to catch two balls to get your ball into the court, right? To get accepted, you have to find two other people. Pyramid scheme, classic example, right? If you have to make money, you have to find two other people or nine other people and so on. Amway and all that, they have obviously, I hope you're aware of that. Otherwise, this will be a very bad analogy to it. So think of that as an example, and this will be something very similar to that. To have a small visual about it, the more the number of transactions keep happening, the pipeline is actually very narrow. So it can only attach one at a time, right? So if we push 1,000 transactions, it will still push one at a time, and it will only go like 35 transactions per second, 20 transactions per second. However, in case of Tangle, it will just keep on growing in multiple directions. The pipeline is essentially a funnel which will keep on evolving and growing and growing. Most of the blockchains obviously follow this sort of pattern, except with some exceptions to the layer 2 solutions. But that's how the Tangle actually differentiates itself. So if we have to, list down the differences between a blockchain and a Tangle, we can probably do something like this. So blockchain is a linked list. Tangle is a graph. A blockchain, the transactions are grouped in blocks, and blocks are validated, right? So in one block of a blockchain, there'll be like multiple transactions in there, and this entire block goes up on the blockchain, and it will keep on attaching one after the other. In the Tangle, it doesn't have to form it into blocks. It can just find two other transactions, and that's about the entire network. Blockchain, obviously, these blocks that are being formed has a size limit, and I think and if you're aware that the Ethereum blockchain went through a couple of forks. The Bitcoin blockchain also went through a couple of forks in which they tried to increase this block size, and now they have reached this sort of sweet spot where they can't increase it anymore without compromising the speed of the network even further. Blockchain, the network requires a certain fee for the transaction, which is the miner fee. Tangle, the way it operates, there is no transaction fee at all, so it's a free network. Truly decentralized network which doesn't charge any fee at all, except for the device or the node that you have to run, which obviously in blockchain also you have to run, but you have to pay the transaction fee as well. Blockchain forms a sequential consensus. So once one block gets attached, the other block after that will try to get attached. Tangle, you can have parallel consensus. So one block is getting attached to one place, other block is getting attached to somewhere else, right? Blockchain, the network gets slower as the nodes increase. In Tangle, the nodes, the network actually gets faster as the nodes keep on increasing. So again, it's infinitely scalable. Blockchain, you have to stay always on chain. Tangle, you can be on chain and off chain anytime. There's also this concept called partitioning, where you can separate out a certain chunk, and you can work on that network, and later on reattach the entire thing to this to the main net, and it will still be one network. To give an analogy to it, think about that you are preparing a car, right? Like you're manufacturing a car, and the steering wheel is being manufactured somewhere else. You can just get it at the end, and you can just fit right in. Your car is good to go, right? So that is the basic difference between Tangle and blockchain. And with that, it enables us to actually step into something really, really interesting, and which is called machine economy. What machine economy means is that you don't need any humans or to interfere in the exchange of information, in the exchange of wherever the transactions is happening. The machines can talk to themselves. They can pay themselves, and they can get things going. which is the very concept on which the very futuristic smart cities are supposed to be built. So imagine, your which obviously I think a lot of you might be aware with the Tesla cars, right, or the Google autonomous cars, which is coming in right now. They are testing it out. They are connected to a satellite, and they just scan the road to see if there are any obstacles, and they will keep on going. Driverless cars. Imagine all the cars are driverless, and now you're just sitting on a cab, and that is just going, and there's other cabs, right, going alongside you, and they can communicate amongst each other, and they can say that, okay, I have to go towards, I have to take a ride, so this car can just slow down, that can just cross over. There is no need for any human interactions at all. In blockchain, this will be very difficult in any blockchain, because there's a huge gas fee that is there. But that doesn't stop Tangle from going along that way. So that actually enables the machine economy. You can go to a gas station, you can fill up like completely an unmanned gas station. You can fill up the gas and or petrol or diesel, and as soon as with the amount of gasoline that gets in your car, the car will automatically pay some amount that you would have already allocated to the car to the petrol pump or gas station, and that's it. You don't even have to worry about interacting with it, taking out your wallet, your credit card, whatever. It just happens right from there, and it is happening right now. People are building solutions and building robots, which is actually doing that. We have seen autonomous medicine, autonomous dispensaries, which will dispatch your medicines by itself. Think about Amazon delivering your package, where multiple bots are flying around and they're communicating with each other, saying that, okay, I'm going to, let's say, second cross fifth lane or something, fifth main second cross or something, and the other bot says I'm going the same way. That, okay, they can just form a sequence and go, or they can just hand over one package to the other bot and go, and only one bot goes and the other one goes back. But this will be obviously very difficult in case of a blockchain-based application. You will have the network, with the increase of network, the increase of more and more nodes and transactions. Once the communication happens, it will probably take a couple of minutes to settle, 15 minutes to settle. By that time, that bot has gone somewhere else, and this bot is gone somewhere else entirely. So it will become very difficult in those cases. So some of the machine-to-machine communications with robots talking to each other is happening. Micro payments is happening with the gas fee or something like that. And micro payments can happen because you don't have any fees right now, right? So think of if you're going to buy, let's say, oranges or apples from your local store, and to buy 100 rupees worth of oranges, you have to pay 1,000 rupees in gas fee. That is not sustainable. I was like, you'll probably just take out your cash and you'll pay him with 100 rupees in cash, or you'll Paytm or Google Play, or do a Google Pay, or do UPI or something. But with IOTA, you can actually do that. If it costs 100 rupees, you pay 100 rupees. There is no extra charge or hidden charge to it. This is one of the main reasons why UPI took over, right? And if you see the amount of transactions that's happening in UPI, it's insane. A lot of applications are now working solely on UPI. Even the platform that we have built is working solely on UPI. It doesn't charge any fees along to it. It does have a fees, by the way, which right now NPCI or the government of India is bearing, which even if it comes back, it will be very, very nominal, like 1 rupee for 100 rupees payment, which is fine. Like you anyways pay that much of that much of fee in terms of large scale monetary transactions. And this will actually also allow the machine to have its own wallet, because it doesn't need anybody else to sign every bit of transaction. The machine can sign by itself. This brings in a new sort of digital age which we are stepping into right now. The trust in data has become paramount right now. So, now that machines are talking to each other, what if one machine goes rogue and something like Skynet happens and Terminator comes into being? So how do you trust that whatever data goes into the system is actually good data? I'm sure you have. I mean, I'm not sure how many people here have seen Marvel fans or something, but you have seen Age of Ultron, right? So if it all depends on how the data is interpreted. So any data that goes into the blockchain is supposed to be treated as correct data. That is not really a good way to go about it. What if I put 100? What if, because of the lack of interpretation, something goes wrong? So you have to also make sure that whatever data is going into into your decentralized network is actually right data, and it is interpreted accordingly. So the multiple signatures that happens on every data validation, it becomes all the more crucial. So trust in data becomes a huge aspect going forward. You have to be very specific on what identity you're using for your application. Real-time transactions, yeah, because of your zero fee, it's actually and because of the high number of transactions that you can process per second, it can become almost real-time transactions. If you pay via UPI right now, it's a P2P payment, right? If you pay via UPI, you get the money immediately. On the back end of it, obviously, the settlement period, it still takes like 2 days for the banks to settle all your transactions or your UPI transactions. But for you, it's almost instantaneously. Like, there's no need for anybody else getting involved in there. There's no wait of, even in the IMPS, you wait for like 30 minutes or something. Even in net banking, you wait for like 3 hours or something on a working day. Otherwise, you could probably wait a day or something like that. Similarly, in this case, also you don't have to wait at all. It's just as instantaneous as they can be. In case of, let's say, blockchain or Ethereum or something like that, this might not be possible all the time. The transaction, however, is instantaneous even in Ethereum. But what if you pay less gas fee? It might not get confirmed. It will come back to you and it will say that, what, this is very less gas fee. I'm not going to confirm this. The validator also will say, I'm not going to confirm this transaction. You have to pay, just add more gas fee to it, just add more ethers to it, and then I'll probably, confirm it. You'll obviously pay more. You will obviously pay more. Recently, I was buying this one domain, and I thought, why not pay in Bitcoins? That was a very, very bad decision, by the way. I could have chosen something of a more stable coinish thing, like say USDT or something, in which it would be like the transaction fee would not be that much. Why didn't I pay in IOTA? Because they didn't accept IOTA. They accepted only Bitcoins and USDT and Ethereums, and I thought I'll just pay in Bitcoins. So the amount that the domain actually cost me was $25, but the amount that I paid in terms of fees was $50. I could have bought like 3 domains for that much of for that extra amount of fees that I paid. So that was really bummer, but lesson learned, and you can also do the same. You can create very smart business models from here. Data-driven open innovation, permissionless ecosystems. You don't have to. So in to scale a blockchain network, you will have to probably make something like a permission public or something like that, right? In this case, you don't have to, because there is no the all the issues that were in the blockchain actually solved in here. So the scalability and everything is pretty okay. So you can build very interesting use cases. Um, I know this one company based out of, I think, Canada or Amsterdam, either of these two places. They were building this. Uh, they were building this vending machine, and you can process you can process payments on IOTA with it. So it'll have a QR code. We can just scan it and pay in IOTA, and it will just drop you the food or drinks or whatever. There's another company who's working on, I think this is also based out of Canada. They were working on this electric charging of a system of the cars. So you can just go there and you can charge, and the exact amount that your car or your vehicle has charged, it will just deduct automatically from the car's wallet to the petrol pump. So it can be even the most nominal amount of fee that there is, right? So a lot of people are right. Another very interesting use case was this another company. I'm not sure where they are based out of, but what they did was, there's if you use any smartwatches or Fitbit watches, Fitbit has this Fitbit payment system, right, built in the watch. It's not available in India. Because of whatever reasons around regulations and all that. Fitbit watch is available, Fitbit payment is not available. So in the other countries where it is available, what they did was they integrated an IOTA node in it. So you can actually run, like, it's so lightweight, the IOTA node, you can run it inside a Fitbit watch. You can run it in a Raspberry Pi. I have run it in a Raspberry Pi. I have a Raspberry Pi 3 Model C here, and this runs a fully compatible IOTA node on it. So it's actually that lightweight to run a full node of IOTA on any of your systems. That gives a lot of advantages because the machine economy works on top of this IoT ecosystem. Obviously, it's not limited to IoT. It can work on, let's say, mobile wallets or mobile phones and other devices as well. You can even run servers and run IOTA nodes on it. But the versatility of it is that you can actually do it on the lightest amount of nodes itself. So just to give how far we have come along in this journey. In this journey, you can see that So if you have to think about the investment layer, like the data, strategy, orders, exchange, security, and so on. So with data, the traditional human economy came up with analysts. Today, then came up quants, which did quantitative analysis on top of the data and figured out which asset is performing good or so on. With future, there'll be oracles which will be self-aware with the real world entity and the network entity, and it will work accordingly. And so on. I'm not going to go through this entire thing. I'll obviously share the slides later on, so you can go through and in detail. But some of the very important aspects of it is the governance that actually got a huge boost with the decentralized ecosystem. So something that came up is something called automated governance, or right now it's coming up as the DAOs, right? Which is a decentralized autonomous organizations. What that means is that you don't have to rely on certain selected people to actually tell you or to set the rules. Everybody is a participant in it. It's a truly democratic system, right? So it's not that we elect a government and then the government runs the country. It's that everybody, all of us, we run the country. If we have to decide on something, all of us decide on it collectively. This is especially very useful in case of, say, some of the use cases that has come out of this are is this taxi app, right? So imagine Uber as a DAO where Uber doesn't decide on the surge pricing. If all the drivers who are driving, they can decide on the surge pricing. They can decide on how much percentage to charge. So if they decide that, you know what, this particular place is and the petrol prices have risen, I'm going to charge 100 rupees. And if all the other drivers, they collectively decided, oh, okay, fine, I'm going to charge, okay, fine, we'll also charge 100 rupees, then the price automatically rises from, let's say, 75 to 100 rupees. Alternatively, you can also, like, the users or as a consumer of that product, you can decide how much you would like to pay for it. So if you think, like now let's say I bring up this pen and I say that, you know what, this is a very special pen, and if you agree to it, you'll probably say that, okay, I'm going to pay 10 rupees for it. Somebody else is going to say, I'm going to pay 25 rupees for it. Now this entering into an auction or a bidding process, right? But this is not exactly a bidding process. This is a voting process. Once everybody settles on a price, the pen's value automatically becomes that. If you see some of the major use cases around this is coming up with NFTs, right? So if Amitabh Bachchan launches, I mean, he obviously launched his own NFT, and will come back to the NFT side of things. And if everybody decides that I want to buy an Amitabh Bachchan's NFT for, let's say, 1 lakh rupees, and somebody says, no, this is not 1 lakh rupees, this is worth 50,000. Somebody else says, this is not 50,000, this is actually worth 10 lakhs, something like that. And if everybody agrees that, okay, fine, this is worth actually 10 lakhs, then the price becomes 10 lakhs. So there is no there is central authority at all into this system. This can obviously slow things down a little bit, but in the long run, this is always favorable. According to this one experiment that somebody did, I mean, you can obviously think that there can be, you know, some malicious node out there, or a group of people who, what if they say that, you know what, we are going to charge 1 rupee for Uber from now on, and majority of the people say, okay, fine, this will charge 1 rupee for any amount of distance, and we don't care about the petrol prices or the hikes and all that. And does that mean that it becomes 1 rupee? It might, right? So that is one disadvantage of a decentralized or an autonomous organization. However, one study has shown that people are inherently not that corrupted as collective thinking goes. So, given a choice, they will always decide onto a very fair path forward, right? There's something to think about, and the DAO is a very deep concept that I think every one of you should definitely look into, read up on. This will definitely affect whatever is coming in the next few years, especially in the IoT ecosystem as well, but also in the entire decentralized ledger technology ecosystem. And with that, let me just welcome you to the future, which is IOTA. If you want to learn more about IOTA, you can just go to this website called iota.org. You can learn more about that on the website itself. And I just wanted to discuss some of the use cases that comes up with IOTA, but I think that will be too much to consume in a single session. So we can probably, you can read about it, and there'll be a lot of use cases that is website itself. So that will be useful to you to learn about. If you have any questions, IOTA has a very active Discord community where I am mostly active. Feel free to join the Discord and ask as many questions as you can, or you can drop me a message or ping me on Twitter or somewhere, and you can ask the questions over there. With that, thank you, everybody. That's all. If you have any questions, feel free to ask them out now. I don't see any comments in there, so I'm assuming there are no questions. This can either be a very good thing or a very, like, either you understood everything and or nothing probably. Are there any other companies using DAG tech? Yes, there are. There's quite a bit of examples. Like there was this other platform called Hashgraph. There's Spectre. They're also based on DAG based. They're also based on DAG based technology. One disadvantage to having a DAG based technology is that because it can grow in any direction. It will require a certain central node to control the flow of the graph, which right now IOTA is actually working on, and it's called IOTA 2.0, which will be a completely decentralized DAG. So that will be a very interesting concept to come into being. It's also a very advanced topic, so you'll probably have to learn a lot more about different about Bayesian fault tolerance in general to understand the consensus that works around it. Okay. I hope that answers this question. Yes, there are other companies who are using DAG. Any other questions? I'm assuming not. So let me just add some of the things that IOTA is coming up with and that I'm currently working on at the foundation. It's around smart contracts, which is coming very soon. Right now, IOTA doesn't have smart contracts like most of the blockchains have. But IOTA smart contract is coming soon, and there's an active development right now. So within a month or 2 months, we'll start testing, having a beta setup to test out IOTA smart contract applications as well. The IOTA smart contracts are right now written in a WASM-based library, so you can essentially write it in Golang or Rust. Rust is the most preferred one, obviously. But there's something very special also coming in that it can also support, or it can run an EVM chain on top of the IOTA chain, which will enable us to run Solidity-based smart contracts. So we've been testing that as well. Working just fine for now. There are certain development things still pending, so we're working on that. All right, if there are no questions, we can probably conclude it here. All right, if you have any more questions, you can probably drop me probably later, and I'll try to get back to you as soon as we can. Thank you so much to IEEE and Amal from the team, I guess. IEEE CS MESCE. It's quite a mouthful, I guess. All right. And yeah, I do hope you start building on top of IOTA. And if you're facing, I'll be there to solve the doubts. Thank you, everybody. Thank you for joining. I hope this was fruitful for you.
Are there any queries to be asked? You can either unmute and ask the questions, or please drop it in the chat box. Sir, can you stop the presentation so that we can present the memento? As a token of appreciation, we would like to present a virtual memento.
All right. So I'm also sharing the slides on the chat. So if anybody wants to take a look at it later on, you can take a look at it. All right. This is interesting. Thank you so much.
Thank you, sir. Now I thank each and everyone for attending the session, and I also thank Kumar and Anirudha sir for making this session wonderful. Thank you once again.
Thanks, everybody. Cheers. Have a good night.